Question 2, first of all, tells us that we have some gallium. We have mass number 69, and that's in percentage abundance of 60.4. So you convert that to decimal form, multiply it by the mass, 0.604. That's going to be added to the mass of our other isotope of gallium, 71, and its relative percentage, 0.396, I get 41.676 plus 28.116 for a grand total of my average atomic mass, 69.792 grams. Second, we're looking for the electron arrangements. The first one for the potassium ion. Potassium always forms the ion 1+, so it's lost an electron. It is 1s2, 2s2, 2p6, 3s2, 3p6. Our second one here is for the sulfate ion, sulfur ion, which always is a 2 negative. So that is 1s2, 2s2, 2p6, 3s2, 3p6. Notice they're in the same isoelectronic series. They both have the same electron configuration as argon because they are the ions of their normal components. So hopefully, again, you did notice that we are dealing with ions here, not the atoms. So you have to plan accordingly. And in part C, we're dealing with the continuous and the line spectrums. So continuous, we have all colors, and in the line spectrum, we just have only specific ones. Or instead of colors, you could have wavelengths or frequencies. All of those would be good answers. Question 3, we had one of these problems in the multiple choice section. We have to figure out how to get to that target equation. So I would multiply the first equation by 2 because I'm going to need 2 of my carbons. So 2 carbons plus 2 oxygens goes to 2 carbon dioxides. My delta H would also be multiplied by 2, so it is a negative 788. My next equation, I'm also going to multiply by 2 because I need 2 hydrogens on my reactant side. So 2H2 plus 1 O2 goes to 2H2O, and my delta H is equal to negative 572. My next equation I'm going to need to flip because I need the acetic acid CH3COOH on the opposite side. So I'm going to have 2CO2 plus my 2H2O forming my CHCOOH plus 2H2O. My delta H is no longer a negative 876, it is now a positive 876. And I want to double check to see if I can get to my target equation, so I look at the things that I can cancel out. I have 2 CO2 on my reactant side as well as my product side, so that cancels out. I have 2 H2O on my product and reactant side, so they cancel out. Did I rewrite something wrong? I did. This should be O2. I have 2 O2 here and here, so those cancel out. So my target equation, 2 carbon plus 2 H2 plus O2 does indeed yield CHCOOH. Now I just need to find the sum of my delta H values. So I have a negative 788 minus 572 plus 876. I get a grand total of negative 484 kilojoules per mole. Part B is an entropy question that will not be on your exam. It was part of an old syllabus.